What's going on, everybody, and welcome to an update to the self-driving cars in Python tutorial series. In this video, I'm going to be giving you an update what's been happening, what changed between version 0.02 and 0.03, what's going on for the future, and all of that. Also, in the last video, a few people were asking, like, hey, where was the demo? There's a 24/7 live demo. Anytime you want to see it, go to twitch.tv/Centex. That's been going on for like 2 months now. So if you're just somehow landing on this and you don't know about that, now you do. So anyway, if you want to see a demo, go there. Now, I will show a couple videos from here, but yeah, the live demo is much more realistic to where the project is. So that's why I really wanted to do the live demo, because it was 100% proof of where the project is. It's too easy as a creator to show your project's best rather than the reality. A 24/7 live demo shows you exactly what's going on. So anyway, I'm always skeptical when I see like short videos of things. So version 0.03, what are the main changes? So the main change that people know about would be the 480 by 270 versus 160 by 90 resolution. So this is kind of for a few things. One is just to see how big of a resolution can we get to, and if does it help. And then also I really wanted to be able to get the neural network to at least have the opportunity to see the minimap. So so that's kind of what I wanted to do here, and sure enough, at 480 by 270, everything's totally clear. Arguably, you probably could have a model that would read that minimap as well, but 480 by 270 has a higher chance. so that's the first kind of major change. But actually, to me, the biggest change is the ability to definitely read the minimap, thus be able to follow and learn from waypoint following data, which then gives me the ability to introduce automated learning, reinforcement learning, that kind of stuff. Because the game world of Grand Theft Auto is very, very challenging. So, if this was just like one of those simple Flash games on, say, OpenAI Universe or something like that, those are very easy to learn. You can run many iterations right out of the gate, and you can train a model relatively quickly on a decent GPU. Whereas with Grand Theft Auto, there's so many more variables. Like with Grand Theft Auto, there's different colored roads. On-road, off-road is different colors. Some of the on-roads are the exact same color as being off-road. There's day, night, rain, fog, police, other vehicles, all this kind of stuff. And while you could simplify the challenge to be successful, I don't see any reward in that, right? Like, why would we simplify the challenge just so we can solve it? That's the wrong way to approach a problem. Instead, let's actually try to solve hard problems. And that's why I'm here in Grand Theft Auto specifically. This is a really hard problem. I don't think anybody's ever solved this problem, doing a pure visual convolutional neural network, or just pure neural network on driving data like this. But no one's done that, right? Lots of people have solved OpenAI's like Flash games. This is not exciting anymore. So anyway, that's that. I don't plan to dumb down the problem. So so that's kind of the main change, and then with reinforcement learning, kind of opens the door to continue on. But one of the problems with this is with Grand Theft Auto, and what makes it a hard challenge, but also a realistic challenge, is we can't run a bunch of iterations of Grand Theft Auto. I mean, if you were really, really wealthy, you could have like a huge server that was just doing like 100 or 1,000 iterations of Grand Theft Auto. Or if you maybe eliminated actually rendering the graphics to a screen, that's always a huge, huge costly thing to do. And my guess is that's what OpenAI was doing initially with Grand Theft Auto 5, but they've stopped that. So that's one thing. You could maybe get it quicker, but no matter what, it's gonna be hard to run many iterations. So with reinforcement learning, with something like that where you can only run one at a time, at least with what I know, you really don't want to use generative evolutionary algorithms. Generative algorithm. You definitely don't want to use a generative algorithm. I could think of a few ways you could do it, but it would not be ideal. Anyway, evolutionary algorithms. You wouldn't want to use that to get to the point of being a good driver. You'd probably want to start as a good driver and then use reinforcement learning to make a great driver. rather than trying to start from scratch. I mean, that would just take years or decades probably with Grand Theft Auto. So at least with a single, let's say a 1080 Ti. So anyway, that's still a little unclear, but I think if we start with a good driver, we can use reinforcement learning to much more quickly just kind of create a great driver. So that's kind of my plan going forward with reinforcement learning and these waypoint data. Moving along to the actual model, I started using Google's Inception, just kind of vanilla v3 model. That's what we used for version 0.02. It worked out pretty well. It took a long time to train, but it worked out. With this one, with the increased resolution literally being the only change, and I suppose waypoint data, I should make clear, about 10% of the training data was waypoint following data. The other thing that's important, I think, about waypoint following is it gives the driver a reason to take a turn. Historically, the AI has really had no aim, no objective, no reason to take a turn. Therefore, basically all he did was go as fast as possible in a straight line, kind of avoiding obstacles until he hit something so hard that his course was readjusted. It's fun to watch, but I grew tired of that. It was not impressive. So yeah. Now, anyway, back down to here. I tried to use just the vanilla v3, which worked in 0.02. Didn't work in 0.03. It started off going pretty well, like within, I don't think I have the time on this one, but within relatively short order, we were already at like 22% accuracy, which is very good. Well, good for a shorter period of time. But then it started to plateau. So this is later on in the model, at step, 40K, 50K, 60K. It just kind of flattened out. And loss was still slowly going down, but then accuracy itself was pretty much flatlined for many hours. This is hour 1, 2, 3, 4, 5, 6, 7, 8, 9. So basically over the course of 9 hours, we just kind of flatlined. So that signaled to me, I mean, we could have continued for sure, but it seemed like something was probably wrong. Like these are just not the metrics you'd be seeing in a successful model. So I thought, let's go ahead and look further. So the first thing I did was decrease the learning rate. So if you do find yourself plateauing, one thing you can do is decrease the learning rate. Or you could just start off right out of the gate with a decaying learning rate every few iterations. You can slowly subtract from the learning rate. And after kind of decaying the learning rate, I was able to actually get accuracy up to 45%, which is a huge, I mean, that's pretty big. When you're leveling out at about 28, you just lower the learning rate, bam, 45. I mean, that was impressive, but still 45, not good enough. So just to be clear, there's 9 output options, so in theory 11.11% would be random. So 45 is much better than random, and to get that huge improvement was nice, but then as you can see, we actually start to come down. So, okay. So then I decided to start modifying Inception v3, and this is the model I ended up with. I went through quite a few iterations, but basically my theory going into it was, look, I know Inception v3 works because I've done it, right, on this exact same data, maybe not the waypoint data, but the other data, and maybe the waypoint was enough to throw the whole thing out, but I didn't think that was going to be the case. So I started, basically logically think about this. Well, the only change is the input layer. It's just much bigger. So an Inception v3 was trained on like the 32 by 32 images, and I'm asking it to read 10 times that, right? Or, well, more than 10 times, but basically 480 by 270 versus 32 by 32. So huge difference. So in theory, you probably could, logically say, hey, well, just take that initial convolution layer and increase that window size. Just make that window much larger, that one window, and then boom, you'd be done. I honestly can't remember. I think I went back and I did try that, and then I compared it to this model here, and I didn't find that was actually better. I ended up tweaking quite a few things, but all my tweaks are contained in this little chunk here. And I can't remember. I think basically this entire chunk has changes. You can feel free to compare them. I called this one Other Inception. But it's still very much Google's Inception. Everything after that is pretty much the same, unless I'm mistaken. I don't think I changed anything else. Coming down to training, once I made that change, man, my nose is so itchy. I made that change, and I was able to get the model to 80%, relatively short order, 200K. I mean, this was actually, I think, really actually over the course of 48 or 72 hours. And after that point, I was like, I was so tired of training models, because while I've showed these pictures, there was so much more along the way. I mean, it was, I think this was like maybe 2 weeks total, or 3 weeks of just trying models, failing, trying models, failing. So that was very frustrating. So at this point, I was like, okay, I'm done. I'm going to push the model and see how it does. So I pushed the model, saw how it did, and again, about 10% of the training data was waypoint data. Arguably, that is one of the problems. I will talk about that in a moment. Oh, the other thing I want to bring up is, aside from adjusting the learning rate to affect, getting higher accuracy, I found that increasing the batch size was huge. And it only makes sense, I mean, because basically you're going to be adjusting, ideally it'd be great if you could take all your data and shove it through the neural network at the exact same time, but in today's world we generally can't have a network big enough, or rather a GPU big enough to take all that data. So initially I was working always with 250 megabytes of data, which in the past allowed me to have about 10,000 samples, but when you increase the resolution, that increases data size significantly. So I was starting off with actually 500 samples per batch. That was a problem. That did get us to about 45% accuracy, though, just to remind you. But then I was like, let's try a bigger batch. Let's do 2K. That improved things. Then I tried 4K. That improved things. And I said 10K. Let's go back to the 10K batch size. And that really, really helped. Now, unfortunately, 10K samples of 480 by 270 is about somewhere between 3 and 5 gigabytes, just kind of depending. So those are pretty big to try to stuff through in a single batch. But it worked out, and that helped a ton. So the batch size was a really big deal, actually. So then to the results. So the waypoint following, initially version 0.03, there was version 0.03, and then there was with the waypoint data. So basically, this was after the first kind of version of 0.03. This is release candidate 2, basically. So this had a little bit more focus on waypoint data, but the whole kind of point of 0.03 was just to see, will it follow waypoints? The answer, of course, is yes. Otherwise, I wouldn't be making this video. So anyways, as you can see, he's got the waypoint there. I think it's pretty clear on video. So yeah, so he's just clearly trying to follow the waypoints. I'm pretty sure, at least in this one, I think he hits a lot of things. Yeah, so he just slams through that card. It's almost like he's like staring at the waypoint data. So he's not as good at avoiding things. But then again, as I've seen this and I go back and compare him to like the actual version 0.0, for sure 0.01, but I also think he's actually better than 0.02. And for sure at nighttime, he's like way better. In the day, he's okay. But anyway, he very clearly follows the waypoint data, and this is just, again, it gives him like an objective to go for, and a reason to take a turn, as opposed to in the past, he really never had reasons to turn. The only reason he would turn is because he made a huge mistake and slammed into something. So with the waypoint data, he actually has objectives, and we can actually score things. The other thing that was kind of cool to see him do is like when he misses turns, so like in this case, he just missed that turn, slams into that car, sorry guy. But then he takes a U-turn to actually go back and get on course, which I thought was just really, really cool. He's not the best at U-turning, and a lot of times he'll miss his objective and then just try to turn through a wall or something like that. So that's kind of problematic. And then here, this is a good example of what I believe to be conflicting training data. So just to kind of frame it before I show it, he's plopped down, I think it was during a reset. So he's plopped down and he's facing forward, total open road. So most of his training data says, go straight, just go straight. But he's got some training data that says, well, we have waypoint data that says you actually need to turn around. So you can see there's quite a bit of conflict in what he's trying to think about doing. So it's like that. Most of his training data says go straight. Definitely don't turn, right? But eventually he ends up succumbing and turning to the waypoint data. And I think that's a problem with having both non-waypoint and waypoint data. Probably should just do pure waypoint data. But yeah, so anyways, I thought that was kind of interesting because you could clearly see he's very conflicted with clear ahead. Why would I turn around? So cool. So as I said before, yeah, some of the issues is he will frequently miss his objectives, or he's just going too fast to take a turn, and then he tries to continue going through. Still crashes a lot, but I think he crashes much less than the other models. Also, he performs way better at night than in the daytime for whatever reason. So moving forward, what I want to do is basically continue on this, because I can actually do reinforcement learning with this data. I'm already logging all of the data to and from waypoints. I actually have a new model that's going to come out hopefully in a few days that is much more waypoint focused, again with automated waypoints. And we'll just kind of see where we can keep going. Now, another interesting thing that I just kind of wanted to show is in the training data of 0.03, well, actually, first I'll play this one. So we dropped him into San Andreas just to see how he would do. So obviously he's got 0 training data in Grand Theft Auto San Andreas. This was kind of funny because I forgot how bad San Andreas looked. Also, San Andreas controls, like, the car's handle crazy. But anyway, so we dropped him into San Andreas, and if you're familiar with the series at all, you probably know the first thing he decides to go ahead and do. So this was actually 0.02, but it was right before the update to 0.03. Yeah, first thing he does is just drive straight into the water with some great music, if I might say so. So, yeah. So yeah, 0.02 in GTA San Andreas. We also put him into GTA 4, but the tutorial is pretty closed, and so we drove a little bit, and he actually did okay. But I'd really like to try him in more situations in Grand Theft Auto 4, so maybe in the future we'll do that. Anyway, yeah, one of the other things I wanted to point out was in my training data, every time I was personally on this stretch of road, I would take that stunt jump, just every time. Interestingly enough, most of the time when he finds himself here, he'll either take that stunt jump or he will attempt to take that stunt jump. So that's pretty cool too. I was pretty excited to see that he clearly recognizes that little environment there and just always goes for that stunt jump. So that's pretty cool. I don't know if he's actually going to complete this one. Wow, I don't know why that would be completed. He was so sideways. I guess he didn't slam into anything. Anyway, here's another one too, where he almost, actually, I think he almost didn't make this one. But yeah, he tried very hard. He avoided that pedestrian, but he was like, I'm taking that stunt jump. Okay, so anyway, if you want to see more of Charles, you can, again, go to twitch.tv/Centex. There's always a live demo there, at least for now anyway. You can come here, you can kind of check out the model, and if you want to apply it yourself, cool. Eventually I might upload just the model. People were asking for the training data, but the training data is like terabytes. So I'm not going to upload that. Don't really see myself doing that. So anyway, other than that, going forward, if you're not familiar, Grand Theft Auto, or actually rather Take-Two Interactive, kind of attacked all the mod creators. Pretty much shut down mods across the board. So we use mods to do things like automatic waypoint setting, resetting the car, invincibility, and then also just if we want to change things like the car, the weather, and all that. So mods are a huge part of us working in this game. At the moment, I'm just running the older version of Grand Theft Auto, but they've been like forcing these reactivations, and you've got to like re-download and then revert your updates and stuff. Oh, it's very annoying. And it's kind of a bummer for someone like me. Like Grand Theft Auto, like honestly, the last probably 20 years of Grand Theft Auto have been modified Grand Theft Autos. And for sure, at least for me, for like the last decade, every the only reason I buy the game is to play it and modify it. So huge bummer that they're just basically banning mods, even in single player. Like I understand the multiplayer stuff, but single player, like, jeez. Anyway, what a bummer. But I'm gonna keep fighting the power, part of the resistance, as long as I can. But that's gonna throw a wrench into things if I get to a point where I can't actually run with mods. That'll be hard. But anyway, we'll figure it out. If you have any questions, comments, concerns, whatever, you can feel free to leave them below. I will, I don't think I have yet, but I'll update GitHub eventually with the new otherception model, but you can also just come to cyber.io and grab it from here. Other than that, really no code changes. I've also been messing around with Granular Throttle. I already had it working. I'm pretty sure I had it working by the time I reported for 0.02. I've continued trying things, but the bottom line is it doesn't perform better than the model I have. Now that's probably because the actual training data itself is done with a keyboard. If the training data was built with an Xbox 360 controller, it would probably do better with that data. So might end up making a hard shift to that information, but at least for now, I want to keep working on the waypoint data and see if we can get reinforcement learning working. Because if I can't get reinforcement learning working, and it doesn't seem to make much sense, there's really no point in changing to an Xbox 360 controller or anything like that. That would just be a huge waste of time. So anyway, I think that covers pretty much everything I wanted to cover. If you have questions, whatever, you can feel free to leave them below. Otherwise, I'll see you in another video.